Assalamu alaikum, boys and girls. We welcome you all to the third lesson of O3 Physics. I'm Khwaja Sajid Nadeer, as you know. Our today's topic is displacement time graph. First of all, we have to see what does the graph means. So anybody knows what does the graph means? You have seen different types of graphs. They are gray, straight lines, curves, pictograms, pie charts. So there are different types of graphs, and all those graphs actually represent some data and it shows the relation between two quantities. So graph basically is a relation between two quantities. If we have two axes, horizontal and vertical. The physical quantities, two physical quantities, are represented along these two lines. Suppose if I consider I'm considering two physical quantities, displacement and time. Time along x-axis and displacement along y-axis. If we consider the relation between these two quantities, as we have discussed earlier, we define velocity What does it mean? It means the relation between displacement and time is velocity. So if we divide the quantity along vertical axis with the quantity along the horizontal axis, we get the relation between these two quantities. So in this case, that is velocity. So before continuing further, we have to consider another thing. First of all, we have considered what does the graph means. The graph means the relation between these two quantities. So it's not necessarily always be displacement or time. There could be any two quantities, and the graph, a line or a curve that will be formed between these two axes represents a third quantity which is related by these two by dividing the quantity along the vertical with the quantity along the horizontal. So the vertical quantity and the horizontal quantity, vertical quantity divided by horizontal quantity gives the third quantity, which will be represented by the line or curve in this section. Another term we have to consider is a gradient. Gradient of a line. What does the gradient of a line means? You people are quite familiar with it. Gradient of a line. Now I am not considering any physical quantity along x-axis or y-axis. I'm just considering a line. If I draw two lines, so anybody can tell me which line has a greater gradient? Yes. The line 1 has the greater gradient than line 2. So 1 has a greater gradient than 2. Gradient means its inclination, its slope. How we find the gradient? You people are already familiar with it. A and B with the coordinates 1, 1 and 4, 4. The gradient of this line you people are familiar with the formula or. Now both these formulas gives you the gradient of the line. So gradient of the line is 1. That is the slope of this line. So there are techniques you are already familiar. You have studied in the maths that the gradient can be found by the formula y2 minus y1 over x2 minus x1, or you can find it as a rise over run. For rise over run, you have to consider the horizontal displacement and the vertical displacement between these 2 points. So to travel from A to B, horizontally I have to move 3 units and vertically I have to rise 3 units. So you can use rise over run, or you can use this formula to find the gradient. If now I have drawn 2 lines L1 and L2. The difference between their gradients, the main difference here, I'm not using any values. I'm just considering 2 lines L1 and L2. One is inclined towards the right, another is inclined towards the left. The difference between their gradient is that L1 has a positive gradient and L2 has the negative gradient. So whenever the line is inclined towards the right, so it has a positive gradient, and if it is inclined towards the left, has negative gradient, irrespective of the quadrants. We don't have to consider the quadrants, just their inclination shows us whether it is positive and negative. So I have to revise this knowledge just to understand the relation between displacement and time, because gradient is representing. If I have a line, straight line, inclined towards the right, it has a positive gradient. If line is a straight, it represents a constant quantity. Relation between displacement time is velocity. So its gradient the gradient of displacement in time graph also represents the velocity. So this line is representing velocity. If this line is a straight, not a curve, then it represents a constant quantity. So in this case, velocity is constant. So first of all, because the gradient of displacement in time represents velocity, so it is velocity. Second thing, we have to consider whether it is a curve or a straight line. If it is a straight line, it represents a constant velocity. It is our first case. Second case. If line is horizontal, its gradient is 0. Because velocity is represented by the gradient, so its velocity is also 0. Gradient of a horizontal line, in this case the graph is a horizontal line. So horizontal line has a gradient 0 because gradient of displacement time graph is velocity. So if gradient is 0, then the velocity is 0. We can say body at rest. Third case. Now in this case, the line is inclined to the left, so its gradient is negative. Its gradient is negative. Because gradient is negative, so velocity is also negative, but line is straight, so velocity is constant. So velocity is again constant. It is negative velocity. In first case, the object was moving away. It is going away. Why it is going away? Because displacement is increasing with time. In third case, the displacement is decreasing. It is coming back. So with the passage of time, the displacement is decreasing. So that's why the object is coming back. So we have considered three cases. First of all, in all these cases, lines are straight. Straight line represents the constant quantity. Because it is a displacement time graph, so the line is representing velocity, the object is moving with a constant velocity. Line is horizontal, Gradient is 0, so the velocity is 0, or is at rest. Line is inclined, straight, inclined to the left, so gradient is negative, but because it's a straight line, so velocity is constant. Though it is negative velocity, because the vector quantity, so it has direction, positive or negative. Going forward means positive direction, coming back means negative direction. But what happens if we have curves? If we have instead of straight line, we have curve, then displacement and time. Displacement and time, their relation is velocity. So their gradient representing velocity. In this case, it is not a straight line, so it is velocity is not uniform, velocity is not constant. Remember, this shape always represents increasing quantity or increasing curve. We call it increasing curve. Irrespective of the physical quantities, this shape represents the increasing curve. So in this case, the relation between displacement and time is the velocity, because it is an increasing curve. So velocity is increasing. Increasing. It is non-uniform. It's not constant. But if I have curve like this, if we have curve like this, so it is a decreasing curve. So decreasing curve means in this case, the velocity decreasing. So the straight lines in the were representing the constant velocity, whether it is positive, it is 0 or negative. But in this case, the curve, if the behavior of the curve is like this, it is increasing curve. So relation between displacement time is velocity. So this curve is velocity increasing. This behavior of the curve shows the decreasing velocity. I hope you understand the concept of the displacement time graph. So remember, displacement and time graph always represents the velocity, because its gradient represents the velocity. So in every graph, we have to look at its gradient. So gradient represents the velocity in displacement time graph. If we replace displacement with distance, we know relation between distance and time is speed. So the gradient of distance time graph represents speed. So displacement time graph was representing velocity, distance time graph represents speed. Otherwise, all the relations techniques are same. If now I'm using distance instead of displacement, time is along x-axis. So what does it mean? Straight line, constant, relation between distance, time, speed. So it is speed constant. Why speed is constant? Because line is straight. It is not a curve. That's why speed is constant. Again, if I take the horizontal line, if I consider the horizontal line's gradient is 0 because it is a distance time graph representing the speed. So speed is 0. Gradient is 0. So speed is 0. You can say body at rest. Distance is not changing. Distance is along vertical axis. It is not changing. It is fixed. So the gradient of the horizontal line is 0. Therefore, speed is 0. The second case, if I consider this line, again it is straight line, so the speed is 0. It has a negative gradient, but because speed is a scalar quantity, so it doesn't carry positive or negative signs. Speed remains same. So it doesn't has a direction, so we don't have to consider negative speed. It is only called as a constant speed. Constant because it is a straight line. So it is not negative. It is always, speed is always positive. If I have this curve, because it is increasing curve, so speed is increasing. And if I use this curve, now you are familiar, it is decreasing curve. So in this case, speed is decreasing. So we have discussed two graphs, displacement time graph and speed time graph. Both are similar graphs. The only difference is the displacement time graph's gradient represents velocity and distance time graph gradients represents speed. So remember, distance time graph, we have to consider their gradients, and the point we have to memorize that if line is straight, the quantity which we obtain by the relating distance and time, that is speed, is constant. Line straight, speed is constant. But if it is horizontal, so because gradient is 0, so speed is 0. Line is straight, speed is constant. And speed is a scalar quantity, it is always positive, it will never be negative. Curve. Now you're familiar with the increasing curve and decreasing curve. Because relation between distance and time is speed, so this represent curve represents speed. This curve represents speed. Otherwise, if we replace distance with the displacement, then the term speed will be replaced by velocity. So that's all for today. And after few minutes, you can ask question related to these graphs. Thank you.